Hi everyone, this is Mr. Lee. In this video, we're going to go over average velocity and acceleration. All right, let's begin. So a good place to start is, of course, the definition and the formulas. So velocity and average velocity, it might sound a lot like the same thing. And in fact, the formulas almost look identical with a subscript that tells the difference between the two. Okay, so the average velocity is the displacement of an object divided by the time over which the displacement takes place. So the big difference from this definition and the definition from before is that we have this subscript AVG for average. This is the physicist's way of communicating with each other. Hey, we're not looking at just any kind of velocity because there are different definitions or ideas that's associated with different kinds of velocity, but we're in fact looking at average velocity, and we'll start to see those differences as we progress through the course. So average velocity is just a displacement over the time. Now, we have this idea called average acceleration. Okay, average acceleration is the change in velocity divided by time over which the velocity changes. So here, I'm going to put a star next to this one. Acceleration is one of those topics that appears throughout the entire course, and it appears in different ways as well. And so with acceleration, we have this formula here, and this formula is average acceleration is the change in velocity over the change in time. So as a reminder, this triangle represents delta, and delta means final minus initial. Okay, and because we have a velocity variable next to it, this is the change of final velocity minus initial velocity. Okay, the units are meters per second per second. So here's the important thing about this unit. Okay, meters per second per second. Sometimes you'll see me write it as meters per second squared, but I need you to know that for the when we start the course, I'm going to be using meters per second almost exclusively instead of meters per second squared. And the reason why is the units tell us exactly the what acceleration means. So meters per second tells us that the velocity, meters per second, is changing for every unit of time, second. All right, so this is how much your velocity is changing per unit of time. And you can see right there, that just gives us the formula from the start. All right, so with that being said, let's go into the other, the details of the definition of acceleration. So an object's velocity, okay, which is, so the change in the average velocity can change in three different ways, okay? So remember, the change in velocity is acceleration. And the way that I like to think about it is, think about if you're the driver in the car, right? You can do three things to change your the way that the motion of the car, all right? So you can either speed up by pushing the gas pedal, so that makes the car go faster. You can push the brakes, which makes it go slower, and you can have a change in direction, which is the steering wheel. So speeding up, slowing down, or changing directions are the three different ways that an object can experience acceleration. Now, I'm about to show you, a little thing on the screen. It's probably one of the biggest misconception of many students in physics. It's very important. If you don't have a colorful pen like I do, I would highlight it, I would star it, I would make sure this is in the forefront of your mind. So the idea of acceleration is that the velocity is changing, okay? Positive acceleration, so by the way, acceleration is a vector. Positive acceleration does not mean that the object is speeding up. Negative acceleration does not mean that the object is slowing down, okay? Now here's an important thing that I don't go into as we continue, but this bullet point right there, all right? Acceleration does not describe how fast something is moving. How fast something is moving is speed and velocity. Acceleration just tells us how much that is changing. So if an object is described as going fast, that statement only tells us the velocity. If I say the object is going faster, okay, that statement is describing the acceleration. Okay, so it's one of those tiny little nuances that many students have a really tough time with. So I'm pointing that out so it's always there on the forefront of your mind as we go throughout this unit. All right, so let's add to it. Positive acceleration does not mean the object is speeding up. this just tells us that the velocity is changing by a positive amount. And of course, I'll show you an example right after it. Negative acceleration does not mean the object is slowing down. The velocity is just changing by a negative amount. And here, now is a great time to remind ourselves, positive and negative, that just tells us direction. All right, so positive and negative are directions. All right. And the reason why I want to point this out is many times students associated positive with one, going fast, which is velocity, or two, speeding up, right? Like they think that positive is like a happy thing or a good thing, but it's not. Or negative is like a sad thing, or it's like kind of making it a little bit slower, right? But it's not. It's just a directional thing. All right, so here's a couple of examples that I want to do. Once again, I would definitely pause the video and jot these down. These are probably the most common mistakes that students make with this unit. Positive acceleration does not mean the object is speeding up, but it's changing by a positive amount. So that's what we had before, and here is our example. If we have a runner with a velocity of 10 meters per second and accelerates at a rate of 2 meters per second, is the object, or is the runner speeding up or slowing down? Okay, so let's look at this in the terms of numerical values and also vectors. Okay, so we know that velocity is 10 meters per second, and what acceleration tells us is the amount that is changing. So what this tells us is, let's say at time of 0 seconds, the object has a velocity of 10 meters per second. So after 1 second, the velocity will now have a velocity of positive 12 meters per second. And this is because here, this is your delta t, and here, this is your delta v, right? It's the change. And as a reminder, acceleration is the change in velocity over the change in time. And so velocity will be 12 minus 10 over 1 minus 0. So this right here, it gives us 2 meters per second for every second. Okay, and that's where those units come in. So this shows us that the velocity is changing by a ratio of 2 for every second that passes. Now, when it comes to vector notation, okay, I'm going to do this off on the side. We can see this by drawing velocity vectors. So let's say at time of 0 seconds, let's say this velocity vector is 10 meters per second. Okay, and let's say at a time of 1 second, we're going to increase that velocity vector right here. This is now 12 meters per second. And so what acceleration tells us is, let's take a look at the difference between the two, right? Because acceleration is delta v over delta t, right? And that delta v is a vector subtraction, right? Which is v final minus v initial. So the v final is this 12 meters per second, and we're going to subtract this 10 meters per second vector. So if I were to draw both, right? If I'm doing my work here, this is the 12 and minus, which is the 10 right here. And so the difference between the two would be right here, right? So we start off at the beginning and we draw an arrow to where we ended. So this vector right here, this is your acceleration vector, because this acceleration vector shows us that the velocity was changing from one moment of time of 0 seconds to a, oops, this should be down here, of 0 seconds to another moment of time here, which is 1 second. Okay, so acceleration shows you how much that velocity has changed. All right, now in the next example here, we get to see how a positive velocity, or excuse me, a positive acceleration can in fact show us if it's slowing down. So if we have a runner with a velocity of negative 10 meters per second and they're changing at a rate of 2 meters per second, right? So at time of 0 seconds, the velocity is negative 10 meters per second, right? But after 1 second, that velocity is changing by a positive amount. So this would be negative 10 plus 2 gives us a total of 8 meters per second. And just a reminder here that that negative just tells us the direction. Right? It's the magnitude that we're looking at. So 10 versus 8. We were faster here, and then we got slower. Okay, so we were fast, and then we got slow. We went from 10 to 8. All right, and so this here shows us that if the the sign of the velocity and the sign of the acceleration are different, we are slowing down. And you know what? That's so important. I'm actually going to jot that down here. If sign of velocity versus acceleration is different, object is slowing down. All right. Okay, very good. Okay, so for this one, this example is taking a look at the negative side of things, right? So here we have a positive velocity with a negative acceleration, and according to what I just wrote up here, if the signs are different, it's in fact slowing down. So let's see if the math shows that it's true. So we have a initial velocity at time of 0 seconds. The velocity is 10 meters per second, and after 1 second, right, the acceleration is -2, so we're changing by a factor of -2, so your v final would be 8 meters per second, right? So we went from a fast speed of 10 meters per second, and we slowed down to 8. So we slowed down there. And let's take a look at this here. We have a runner with a velocity of 10 meters per second and accelerates at a rate of -2 meters per second. So remember the rule of thumb, if your velocity and your acceleration signs are different, that slows down. If it's the same, that means it's speeding up. So our time of 0 seconds, our velocity is -10 meters per second. And after 1 second, we know that the velocity changes by a -2. So this should be -10 plus -2 gives us -12 meters per second. So in fact, we are speeding up. All right. Ladies and gentlemen, that's it for average speed and acceleration. I'll see you next time. Bye-bye.